Welcome back, crew, to lesson 5 of our Scratch class. This week, we are going to learn about gravity, or as James Brown calls it, the big G, or as James Taylor calls it, gravity. You'll see gravity in a lot of games. Pretty much, I think every platformer has gravity in it. Okay, focus, Ted, focus. Why are we here? We are here to add gravity to our Scratch program. Okay, so let's start by exploring the word velocity. People often use the word velocity instead of the word speed so that they sound smarter than they are. That's what I just did. To be strict about it, the word velocity actually means both the speed and the direction that your thing is traveling. Did you know that velocity can be broken into two parts? It's horizontal and vertical components. And to that you say,
"Those words are meaningless, Ted."
Well, control that rage and direct it at your parents, because I want to go on a journey to visit the interstellar soup dumpling whose name is Xiao Long Bao. Now, did you know that if Xiao fired crab soup downward, the dumpling would fly upward? Now, if Xiao fired the soup leftward, the dumpling would shoot off to the right. Now, here is the key bit. If Xiao fires both thrusters at once, it will have a velocity that sends it on a diagonal up and to the right. And it turns out that for modeling gravity in code, looking at velocity as a combination of its horizontal component and its vertical component, like the two thrusters, is actually going to make it easier, because gravity is only going to apply in the vertical direction. And you're going to see how this works out, and you'll be like, "Oh, Ted, you were right, turns out." And I'll be like, "Yeah, okay." You know what it's time for? Geek of the Week! This week's Geek of the Week is Grace Hopper. Do you know that we wouldn't have Scratch without Grace Hopper, in my opinion? Even though she was born over 100 years ago, back in the early days of programming, we owe her a lot, because she's the one who made programming readable. She said, "Why can't programming languages be made up of English words and such instead of ones and zeros and cryptic commands?" She served in the U.S. Navy as a rear admiral, and she liked giving people nanoseconds. She walked around with this piece of wire that was about a foot long. She had a whole bunch of them, and she'd say, "This is the distance that light can travel in 1 nanosecond." I really wish I had one of those nanoseconds, but they don't make them anymore. Let's start with a super simple program to model gravity. Then we'll make a little game that uses it, and then we'll sell that game for millions of dollars. So we'll create a new project, and I'm going to name it Gravity. You're going to name yours whatever you want. Then we'll do the usual and start by reacting to the green Go Flag event. Then we'll send Scratchy to the lower left to prepare for a jump that's going to follow the rules of gravity. I think we're going to need 3 variables. One is for the x velocity. Think the left dumpling soup thruster that we saw before. And one is going to be for the y velocity. Think the bottom thruster on the soup dumpling that we saw before. And the last one is going to be for gravity. And gravity is going to be the hidden force that keeps us all down, except for my best friend Mike Powell, who could jump the length of a school bus.
I don't know you, Ted, and nobody watches your videos.
Sorry, virtual Mike Powell impersonator. Let's initialize these variables. Let's say x velocity is 5, so Scratchy moves horizontally 5 steps each iteration of the loop. I know you're saying, "What loop?" But we're going to make that loop in a moment. So let's say that the y velocity is 20, because we're going to need it to be a big upward thrust, because we're going to be fighting gravity, and so we really need some oomph here. Then we'll make gravity just be -1, so it's that negative force that's going to be pushing down on Scratchy. Now we're going to make a loop. Here's the loop. We're going to make it loop 80 times, because 80 is the largest number that I know. Then we will animate the sprite moving in this loop. And we need that little weight that we always put in, just so our eye has time to see the sprite in each of its locations. Now we're going to apply gravity. Every iteration of the loop, gravity is fighting the y velocity of Scratchy here. We're always subtracting 1 from the y velocity, and as you might have guessed, when Scratchy reaches the peak of her jump, that's when the velocity, the y velocity, has been reduced to 0. Since gravity never stops, it's going to send the y velocity negative after the peak of the jump, and Scratchy is going to start to fall and fall faster and faster. Oh, now the final step here in coding is to move Scratchy. So we're going to say the new x position is just the current x position plus the x velocity. And the new y position is the same kind of thing. It's the y position, that's where it currently is, plus the y velocity. It's just that gravity is always changing our y velocity. Okay, let's run this. And yeah, it looks pretty good. It looks like gravity. So, I think I want Scratchy to jump just a little bit further out to the right. So I'm going to add a little bit to the x velocity. And then I think also the wait I have in there is a little bit too long, so let's speed up the whole thing by making it just wait 0.01 seconds. Okay, let's play with the gravity a little bit. Let's try negative 0.5 as the gravity and see if it gets floaty. And then finally we'll see what negative 2 gravity looks like. And then other than that, the only thing you need to know is that Elvis would weigh 13 pounds on Pluto. Okay, guys, let's make a game that uses gravity. So let's have Scratchy try to catch a bat named, well, Batty. We're going to do what we always do. We're going to go search for T. Skolnick. And this time, I want you to find the Gravity Sprites project. You click on it, you hit the remix, and then the next thing you know, it's yours. So once you're inside there, you're going to see that I've got 2 sprites. I've got Scratchy and I've got a bat. I also have Scratchy filled with the exact same code, the stuff that we just wrote for applying gravity to a jump. I just want to change 2 of the values here. For starters, I'm going to make the x velocity variable 0 so that Scratchy's not sliding to the right or to the left, just standing right in the middle. Then for the starting location, I'm going to put Scratchy at negative 50 for the y position because I hereby declare that negative 50 is the ground plane. So we'll run it, and it looks great, except for Scratchy descending into the depths of hell. So let's make Scratchy stop on the ground plane, and I can do that just with an if statement. And the if statement is going to say, if the y position of the sprite is less than 50, then make it 50. And so at that point, it gets stuck right there. It won't go below 50. Now, I think we can animate the bat. You can see here that the bat has a sequence of costumes that we can just step through to make the bat look like it's flapping. So let's just attach a forever flapping loop to the start event for Batty. I do the usual. I put in a little wait to control the timing. I think 0.2 seconds is going to be good. And then we test it out. It looks flappy. Now we'll create another forever loop when we start and have this one control the flying about business. I think I always want to start Batty in the upper right, so I'll just put a go to for that. Then in this forever loop, I want to have Batty change direction, but I want to make it small. I'm going to choose a random number between -5 and +5 and make that the direction change that Batty will make while flying it. And between -5 and 5 is just tiny little counterclockwise and clockwise movements. Then we move 10 steps, but we don't want to be stuck on the edge, which can happen. So I'm going to toss in that if on edge bounce block, and that's going to work nicely. Finally, I'll do a weight of 0.05 to control the flying speed. And that looks great, except for the flying through the dirt part. So let's add an if statement to make sure that Batty stays in the sky by saying that if Batty drops below a certain y value, then point Batty back upward. In the code, you can do this just by saying if the y position of the sprite is below 80, then point in a random direction, but limit that random direction to just the upward directions. And in the Scratch world, that means the angles that go from -90 to 90, those are all upward pointing. Let's take a deeper look at that last bit of code. We don't want Batty flying into the dirt, so we're going to set this imaginary wall at y equals 80 that Batty can't fly below. Batty starts flying randomly and then suddenly decides to take a nosedive right for the dirt. That's when our if statement asks if Batty's y position is less than 80, then we want to act just like that bounce if on edge block. And to bounce, we just need to point Batty in an upward direction. If you recall, in Scratchlandia, the angles between 90 to -90, they're all upward pointing. So if we pick a random number from negative 90 to 90 as our direction that we're going to point in. That's all good, and we'll be headed upward. And Batty will bounce off the imaginary wall at y equals 80 and fly back up. Let's give it a try. We'll watch Batty do that bounce off the imaginary wall, and that's it. Now, Scratchy needs our attention. Okay, let's respond to the spacebar event to make Scratchy jump. Okay, I'm going to say that you really need to be on the ground to jump. So let's ask if Scratchy's on the ground just by saying if the Y position is negative 50. And because remember we picked negative 50 earlier as our ground plane. And it looks like I put a positive 50 in there. Let me just fix that. Okay, so we got negative 50, and then we're just going to set the Y velocity to 20 because that's what a jump is. It's a sudden upward velocity. And I think I'm just also going to do another thing. I'm going to set the very beginning of the program, I'm going to set the Y velocity to 0 so that Scratchy isn't jumping right at the start of the program anymore. Now, let's make Scratchy move to the left and to the right. And this is going to be so similar to the jump that I'm just going to copy that full event. Again, I think for the left and right movement, we're going to have the same rule. You got to be on the ground. So we have that same thing if Y is negative 50. So for going to the left, we can just say the x velocity equals negative 5, and Scratchy will head to the left. And for the right arrow, it's going to be the opposite. Okay, let's duplicate the left arrow key. We'll take that same event, and we'll just convert it into a right arrow key event. Okay, right arrow key. Then the x velocity is positive to go to the right. So let's do that. We'll put in a positive. And then we'll hit right. We go to the right. Left, we go to the left. It's working, except for Scratchy's not pointing in the right direction. So let's see if we can fix that. And this is mildly amusing because I keep doing it wrong. You'll watch me do it wrong a couple times. Hold on, here we go. All right, so I was smart enough to pick the point in direction thing. So I'm going to point in direction. And here I should have picked negative 90 because it's the left key, but I picked 90. And then for the right key, I should pick 90, but you'll watch me pick negative 90. But we'll fix it up. Just be patient. I don't know. We'll watch through this. We'll do some debugging together. Yeah, let's put a positive spin on this. Okay, so let's watch it. Look, he's backing his way across the screen. And I'm like, oh, what a dope. I should have fixed that. Okay, so then I'll fix this one up. So the right arrow is now 90, and somehow I still left the left arrow as 90, so they're both pointing to the right. But this is an important bit. This set rotation style, I want that to be the left-right rotation style, even though it was working. If you don't have that set, it'll be the kind where he flips over when you turn to the right, or he flips back if you turn to the left. It'll be like an actual rotation. So this is just the flop mirror kind of left-right. So okay, now I got it all fixed up. And yay, we did it. Moving on. Now we need to have the bat actually catch Scratchy. And that's the bitter irony of it all. To do that, I want another forever loop that starts when the program starts. And that's just always asking if this sprite is touching the bat. If it is touching the bat, then we're just going to turn off the gravity by setting it to 0 so that we stick to the bat. And then we change our position to be that of the bats. But we don't want to be like right on top of the bat. So really, we're going to match the X position of the bat. But we need to subtract 50 from the Y position so that bat is right at Scratchy's head. So it looks like Scratchy's going to hang from the bat. Okay, let's hit the spacebar, make Scratchy jump. It will trigger the if statement that says if touching bat, we'll set the gravity to 0 to help us stick to the bat. And then that go to bat position helps us stick to the bat forever. Oh, we are so close. So I just want to do one more thing. I want Scratchy to feel deflated when his fate takes this dismal turn. And oh, this is going to be fun. So what we do is so we'll do this one last forever loop, checking to see if Scratchy is touching the bat. And if so, we'll step through the 2 emotional collapse costumes that I put in there. Okay, so I'm just going to grab and duplicate that existing if touching bat part and then take out the insides, because if I'm touching the bat, really all I need to do is step through the couple costumes for that deflated look. It reminds me, I should make sure Scratchy's wearing the proper costume right at the very, very beginning. So I'll set that to be the first costume. It may have been left in a different costume. For some reason, I have these costumes out of order. Costume 3 came before costume 2, but, I screwed up. For some reason... Shush! Let's get back to the inside of this if statement. So let's set the costume to costume 3 for the first of the 2 deflated looks. Then we'll put in our weight like we always do. And then we'll set it to costume 2, which is the final look because I messed up the costume order. And then I'm going to put in a really, really long wait after that, just so he stays with that costume, because really the for loop is going to keep checking forever. And if I didn't put a long wait, you'd see what happens. Try it. You'll see what happens. You'll see what happens. Okay, let's run this thing in its final form. We jump, we'll get caught by the bat, and we fly around. Then you see the sequence where with the deflated look, and I think we did it. I think we are great programmers as always, and I just want to thank you for coming. Stay well, and I'll see you next time.